So now we're going to put together everything that we learned in Chapter 3 into one big example, and it'll recap the whole chapter for us. What's more, we're also going to be doing this from a computer output that was given to us, namely down here, the StatCrunch output. Now, why is that a valuable thing to know? Well, a lot of times in your future work or your future coursework, if you're in a class that uses statistics, they'll actually have done a lot of the number crunching for you with a computer program. And the question is, can you analyze it and go further beyond what they gave you and to make good decisions or to make good interpretations? So we're going to have these types of questions periodically in the course. Okay, so we have a group of business students wanted to study the amount that the U.S. exported to different countries last year on average. They gathered data from a random group of countries the U.S. exports to, because we don't export to every country, so it's just from the countries that we export to. And then we calculate how much in goods and services the U.S. sold to those countries last year. Some of the countries are shown below, as well as the summary statistics of their findings with StatCrunch. Okay, so I'm not giving you every country because I don't want you to actually use my full sample to be able to do the problems with your calculator. That's not the point. The point is, can you analyze the StatCrunch output right here and figure out what's going on? Okay, so let's begin with the population in the sample. Now it's a little weird. I actually kind of like figuring out the sample first because it's usually given to us somewhere in the paragraph, and then we can kind of infer from there what the population was. So the sample is the random group of countries that the U.S. exports to that were researched for this study. So that would be our sample. And our sample size is in the output, and it's 19. It says little n is 19 right there. There, I've highlighted that in a little purple box for you so you can see. All right, now what is that a sample of? Right, the 19 countries that they sampled were 19 countries that the U.S. exports to, and that is a sample of all the countries that the U.S. exports to. A quick Google search reveals that that is 75. So there are 75 countries currently that the U.S. has trade relations with. Now, keep in mind that's not all the countries in the world. So there are 195 countries total in the world, and we don't export to all of them for whatever reason. So 75 countries the U.S. has official trade relations with. So that's probably the population. All right, so now what type of data is the variable U.S. exports and what level of measurement is it? And then what's its unit of measurement? Okay, so U.S. exports is right here. It's these numbers in this right-hand column. Now notice that's not the sample. One of the big mistakes students make is thinking that these numbers are the sample in the right-hand column. The sample is the countries, and the data over here is just something that we measured about those countries, how much the U.S. exports to those countries. But the sample itself is the countries, and as is the population, right? It's all the countries. All right, so what type of data is this? Well, it's obviously quantitative. For example, it's numerical, but it's numerical in such a way that we can do meaningful calculations. So it's not something like, zip codes or something like that. So we know that we export more to Switzerland than we do to Thailand, and we can figure out exactly how much more we export to Switzerland. Right? Now, we know it's quantitative. Now the question becomes, is it nominal, ordinal, interval, or ratio? Well, nominal is only for qualitative data, so that's out. Ordinal is almost always for qualitative data. The exception to that would be like a pain level scale of my pain level's at 7, my pain level's at 9, stuff like that. Although if you're at 9, you're probably crying. It's usually out of 10. So quantitative is 99% of the time interval or ratio. Now, interval is the one that can have negative values, and ratio is the one that cannot. So if we look at our data set, this is the amount we export to these countries. That's not our trade relationship overall, because the trade relationship overall can be negative. For example, if we import more from Switzerland than we export to Switzerland, which I believe we do, then that becomes a negative relationship for us. Right? But that's not what we're talking about. We're just talking about how much we export. Well, export, the lowest amount you can export to a country is 0. Right, if you export nothing to that country. So that would be ratio then, right? Cannot be negative, so it's got to be ratio. Okay, now the next bit, a lot of students get confused about the level of measurement. and the unit of measurement. They're not the same thing. Level of measurement saying, hey, nominal's low level of measurement, ordinal's better, interval's even better, and ratio's the best, right? Those are kind of the way that goes. Unit of measurement is more what were the units possible for your data set, which in our case is $1 billion. That's our unit. And you can see it with this little aqua box right here. So $1 billion here or up here, either way, $1 billion is your unit of measurement. And based on context, we can assume that that was billion US dollars, not like Canadian dollars or something like that. So US dollars. Now, are the values found by the computer above parameters or statistics? Explain. So that's talking about this output again. So all these values that are found, the mean, the median, the mode, all that jazz, are they parameters or are they statistics? Well, they're statistics because statistics, S, goes with samples, right? Remember, S goes with S and population goes with parameter. So P goes with P, S goes with S. So because these were from a sample, these are statistics. All right, now this one's a little tricky. Does the purpose of this study appear to be descriptive or inferential? Well, we talked about those just briefly in section 1.1. Descriptive is I want to just describe what I see and that's it, right? What's in this data set, what's in the sample, and that's all I'm trying to do. Inferential is saying, hey, yeah, I want to describe what's in this data set, but I want to infer from this data set about the larger population, which seems to make more sense in this particular context. They're probably not interested in just these 19 random countries. Maybe those are the only 19 they had for whatever reason, but they want to make inferences from there about the whole population of all 75 countries that we export to, or perhaps all 195 countries, who knows, in the world. So if they want to make an inference from a small group to a larger group, right, from a sample to a population, then that's inferential. And that seems much more likely in this case, right? They're probably not just interested in looking at the 19, they're interested in overall, how much does the US export to different countries? So we'll say inferential because the business students are not just interested in describing the U.S. relationship with those 19 countries. That would be descriptive, right? If they just want to look at those 19 countries and that's it, just describe it and walk away. But they more likely want to infer, right? They're interested in using those sample statistics to make inferences, sorry about that, about all the U.S. trade relationships. All right. Next, all right, so let's look at the mean, the median, and the mode. Let's start there. So the mean, the median, and the mode were all sitting there nice in a row for us, right, which is in the data set. Oop, hold on one second. There they are. So the mean is 29.638. The median was 637, excuse me. The median is 18.3 and the mode is 10.3. Now keep in mind the unit for all of these will be $1 billion. So that would be the unit for every single one of these, except for the variances. They're a little weird, but everything else would be $1 billion. All right, so let me go type up those responses. All right, so there are those three values. So they each have a unit of $1 billion, and there they are. So now what about the standard deviation? Now the standard deviation was not given to us in the problem, but they did give us the variance. Sneaky. And then even more sneaky, they gave us the unadjusted variance. Okay, so those two are both the possibilities for what we need to use. We want to use variance or unadjusted variance. It's got to be one of the two. But the thing is that we have to remember back to section 3.2, what's the difference in those, right? Because the standard deviation is the square root of the variance, but which one should we use? Because there's two given to us. So let me go back to section 3.2 real quick. All right, here in this ginormous table, we had all sorts of information about variance and standard deviation. That's all proved to be pretty useful stuff. Hint, hint, hint for your note sheet for your exam. So this bit right here is what we're about to use, right? The variance and the standard deviation have a relationship. Namely, that the standard deviation is the square root of the variance, i.e. the variance is the standard deviation squared. All right, so we'll keep that in mind, especially the one on the left. And then we have to remember that there's actually two flavors. There's the sigma values if your data set was a population, and there's the sample values, S, if your data set were statistics, if it was a sample. Well, since ours is a sample, then we totally want S and S squared. All right, now how does that help us? Well, it doesn't entirely, other than we know what we want. And then we notice this little bit right here. It says that sigma and sigma squared are called the unadjusted computer outputs. All right, that's key, because the sigma one, then sigma squared one, I should say, is unadjusted. So if we look back at our output that we're looking at, the one that says unadjusted is actually sigma squared. But we don't want sigma squared because we have a sample. We want S squared. So we're going to use the other one, the one that's not unadjusted. So let me scroll back to our problem. So I'm going to label them here. So the one on the left is S squared, right? So it's saying, hey, these 19 countries, they were a sample. This would be your variance. And the one on the right is, hey, these 19 countries were a population. This is your variance. So you have to choose the correct one. And because our data set was a sample, we're going to use the S one, not the sigma one. Now, if we happen to have a population, let's say it was just all 50 states and all 50 were given to us or something, then we would use the unadjusted one because that would be appropriate. So you have to use whichever one's appropriate for your context. All right, so we're going to use S squared. And then we're also going to use the fact that the standard deviation is the square root of the variance. So we would take the square root of that number and we would get, hold on, I gotta grab it with the computer. There it is, 38.189. Now how do I get that? Well, you can see it right there on the calculator. I took the square root, which is above the x squared button here, square root x squared button, so second x squared, and type 1458.3991. And lo and behold, 38.81 or 189. And there we have it. That's the standard deviation. All right, now what about the IQR, the lower fence, the upper fence, and the range? Well, those are all found with the 5-number summary, which 4 of those numbers are here on the back right end of this box, the min, the max, Q1, and Q3. The median is the only one missing, and that's because the median's farther over to the left. All right, so let's start with the range. I mean, it's easy. Range is min, max, or sorry, the difference between min and max, which is max minus min. So I'm going to use that fact to find that value. One second. Because we're going to be using these values, I highlighted these two. So these two I highlighted in like an orange color and then green. So to find the range, we're going to use the orange ones, which is max minus min, right here. So you take 160.48, you subtract away 4.8, and you get the max minus min, which is 156 billion, dollars, which is equal to your range. Easy as that. Now IQR is the interquartile range. The interquartile range is Q3 minus Q1. So we're going to take Q3 and take away Q1, which is 26.6, take away 10.3, which leads to 16.3 billion. Now the lower fence, we learned that formula for that in section 3.4. That is Q1 minus 1.5 IQR, which is 10.3 take away 1.5 times 16.3. Now, a lot of students do this incorrectly, so let me just type this real quick. 10.3 take away 1.5 times 16.3. Close parentheses, enter. So what you don't want to do is do 10.3 take away 1.5 first because of order of operations, right? Please excuse my dear Aunt Sally, PEMDAS. Multiplication, 1.5 times 16.3, wins out over subtraction. So you have to do the multiplication first and then do the subtraction. But if you type it all at once in your calculator knows the correct way. So it will do it all at once if you just type it in one line. All right, now the upper fence, there's another formula for that. And again, lower fence and upper fence formulas might be a very smart thing to put on your note sheet for the exam because you don't have to memorize them, you just have to use them. So the upper fence is Q3 plus 1.5 IQR, which is 26.6 plus 1.5 times 16.3, which would be $51.05 billion.